In a finite geometric sequence, term 1 is 7, so we know term 1 is 7. We don't know term 2, term 3, term 4. We know term 5 is 567. We don't know term 6. We want to find term 2, and we want to find term 6. Wouldn't it be nice if we knew what R was? Because if we knew what R was, it'd be easy to find what the next one would be. So it's sort of, this question, by looking at it, makes me think, I probably want to find R. Well, what do I know? And I'm going to solve this in two different ways. Okay. I'm going to say, well, I know my formula for a geometric sequence looks like this. Can I put stuff into this formula? So the only thing I don't know is R. Okay. I know term 1, so I definitely can plug that in. And since I know term 5, I can say I'm going to make n equal to 5. Then term 5 is 567. Term 1 is 7. R is 3. Oh, sorry. I gave it away. I don't know R, supposedly. But then I would know this is 4. Actually, R could be more than one thing. We're going to find that out. How do I solve for R? Well, I'm going to divide both sides by 7, so I take out my calculator. I divide both sides by 7. I get 81 equals R to the 4. What do we do to get rid of that 4? We fourth root both sides. Fourth root this side, fourth root this side. That will give us R by itself. And fourth roots, sixth roots, eighth roots, 12th roots, 10th roots, any even roots act like square roots. What did you have to remember when you square rooted both sides of an equation? Ooh. Like if I had x squared equals 16, what's x? 4. Close. You're right. Could be 4. Is that the only answer? No. Could also be something negative. Could also be negative 4. Right? Because negative 4 times negative 4 is 16, and 4 times 4 is 16. When we square root both sides of an equation, we have to remember to add a plus or minus, because it could either be positive or negative. The same thing happens with 4th roots, 6th roots, 8th roots, 10th roots, and even roots. You have to remember a plus or minus. So the answer could be plus or minus 3, which means that if I multiply, this one could be 21 or a negative 21. This could be, I'll take out my calculator here, 1701 or negative 1701. Little reminder, when something is telling you to find, or when something tells you it is the last term, what that means is we make this term n and have to find out what the n is. So the Tn, sometimes we talk about standing for the general term, anything in the equation, but sometimes we talk about being the last term. And that's a specific general term we're looking for. So part B, if I know the last term is 45,927, I can plug that in for Tn. I know that term 1 is 7, and I have solved that R is either plus 3 or minus 3. So the question is, Which one am I going to use, and does it matter? It might matter. So I'm going to use the positive 3 because this number is positive. So it's going to work for sure if I use the positive 3. It might get an error if I use the negative 3 depending, because you see that the negative 3 one would alternate between being positive and negative, positive and negative. So I'm going to assume it is the positive 3 and see if I can solve for this. And now you are going to be tempted. Math does this to you. Math will sometimes tempt you to do things that's not allowed. Okay? Do you see this 7 times 3 right beside each other? You are going to be so tempted to write 21. You're going to be like, sort of like, show your paper off to the person next to you like, I know my times table. 7 times 3, 21. You're going to be tempted to show off your times table, but you are not allowed to multiply the 7 times 3 right now because of order of operations. Order of operations say, what do we do first, multiply or exponents? Exponents. This 3 has an exponent of n minus 1. You have to do that exponent first before you multiply. The problem is you can't do that exponent because you don't know what n is. So you will be tempted to be like, oh, maybe I'll just skip that for later and do the 3 times 7. You're going to run into problems if you do that. Okay, well, what could I do? Well, it's an equation. So if I divide both sides by 7, that would be fine. If I divide both sides by 7, take out my calculator. Thank you. 6,561 will equal 3 to the n minus 1. And now this is going to bother you a little bit because you're pre-calculus students. Pre-calculus students, we like to solve things all algebraically all the time. Unfortunately, the algebra to solve this from this point requires grade 12 math. You would have to know how logarithms work and how to use them. I'm looking at you, at the faces. Nobody's eyes went like, yeah, I know exactly how using logarithms work. No? No. So, we're going to have to do a little bit of guessing and checking and a little bit of logic. The logic is that n has to be a nice number because it's a sequence. It's not going to be a decimal. It's going to be a nice whole number. So we are going to take out our calculators and we are going to test 3 to the something has to be 6,561. Pick a random number. 9. 3 to the 9. Oh, you went too big. But now, as far as guessing and checking, do you know that it has to be less than 3 to the 9? Pick a number less than 9. 8. Oh, you guys got it already. Other class took them like 5 guesses. Right? So now we can change this to 3 to the 8. And now you should be able to just look at this and tell me what n is. Got it. N is 9. Why? Because if these are equal, does it make sense that this has to equal this? No. And it's like, oh, it's so complicated. N minus 1 is equal to 8. How can I possibly figure out what n is? And n is equal to 9. Okay, so questions we can circle on this one are 8, 9, and 11.